Alright, so now we are going to look at deriving, trig and exponentials, and the reason we're doing them is because they are largely very similar. A lot of us are applying polynomial rules to these and we need to fix it up. If you can't do this, this is a walker. This is a free marks on the exam. If you get anything like this, these need to be absolute walk-ups. Now I've given you three different forms, but they're very, very similar. I want you to attempt to write down the derivative of each of those functions as best you can, and then below I'm going to provide us an example. And we'll see how we go. Just 10 more seconds to get the general rules down for each one of those. So Max, what do you reckon the rule for the exponential is?
Derivative of the brackets to the power of...
Yep, so f dash x, the derivative of the power.
Yeah.
What about it?
Times with k.
Times by k.
And then e, and then just this e to the x.
Who agrees with Max? I do, very good. So if we're doing this example, and the way that I like to do it, if you're unsure on this, and when you start approaching these problems, I just rewrite everything that I know I'm going to have to do. I know that I don't have to keep this exactly the same, right? So I just put at the end e to the 4x, because that's going to be there. It's not going to change. I already know that. I look at the question, I already know that. I know that the k, well, nothing's going to happen to it. It's just a coefficient, correct? And then at this point I start asking, well, now I'm dealing with a derivative problem, what do I do? Well, I multiply by the derivative of my power, which is 4, and then I simplify. Happy with that? So my process when I'm solving that, and that's dy dx, sorry. My process when I'm solving that is to write down the easy parts of the question straight up. I know that the exponential is unchanged by the derivative, so I want to rewrite that. I want to rewrite the coefficient because it's unchanged. Then the last thing I do is deal with the thing that is different, which is the fact that I'm multiplying by the derivative of the power. Cool? So what's the rule for our second one? What do you reckon, Bax?
Same. F dash x.
F dash x.
Times k sine f of x.
So understanding what you know about how I solve these problems, what's the first thing I'm going to write when I solve the example below? What's the first thing I'm going to write? Oh, it is cos, very good. That's right. Cos of fx. So the only thing that's different about this is in this situation the exponential is completely unchanged, correct? What happens in the sine example? It becomes, what happens to the cos? It becomes? Negative sign, very good. So knowing about how I solve these problems, what would you reckon I'd write first? I'd write cos 2x. Notice that I leave the brackets completely unchanged. They're exactly as they were originally. What do you reckon the next thing I write is? 3. And then I put times 2, 6 cos 2x. Happy with that? Actually, I'll make this positive, but it's okay. What's this one become? What do we reckon, Josh?
F dash x.
F dash x.
Oh, so put the negative in front.
Yeah, we can put the negative there, but negative f dash x
K, times k.
times k.
Times sine fx.
Very good. What do you reckon the first thing I do here? What do you reckon, Sophie? Yeah, I can do that, but if I was doing this problem, you know how I solve these problems, what do I always do first? write the part that I know before I have to even do any derivative. What's that? I turn my cos into a sine. What do I do to the bracket? Leave it the same. I write my -4 and then I multiply it by what Sophie was saying, which was the derivative of my inside, which is, what have I forgotten? I've forgotten something. My negative sign. Cool. Two negatives, mate. So I've got 8x sine x squared. Awesome. Now these are all shortcuts. What are they all shortcuts for? What rule? Chain rule. Okay. You can go about it however you like. I like to go about it that way because that reminds me every time I do one of these problems that the thing inside the bracket, the thing that I'm deriving, stays exactly the same. Are we happy with that?
Yes.
Cool. Walk up questions. Now often we don't just ask these questions in isolation.